Alright, so back to it. Now it's time to create the service in our application. So as you can see in this diagram, we already created the model, cross that out. We created a repository, cross that out. So now it's time to create the service, and the service is simply a layer between the controller and the repository. It encapsulates the application's logic, controls transactions, and coordinating how responses should look like when those operations are finished. So we know that the controller was taking a request and funnel that request to the service after finished validating the structure. We're going to take that structure of that request, we're going to implement some logic, and with that logic, we're going to define what the needs are. So whether the person wants to insert the data, whether they want to get some information, all this is, logic that is done within the service. It's structured back into the controller, and that controller sends the response back to the device. So let's start creating the middleman between the controller and the repository. Alright, so let's start coding our service layer for our application. But before we start, let's brainstorm a little bit. So what do we expect from our service layer? What do we want from our application? So for a simple to-do application, we expect to be able to add a to-do. We expect to be able to update a to-do. We want to be able to retrieve all the to-dos from the database, and we want to be able to delete a to-do. So those are 4 functionalities that we'll do. Each one of those actions will require their own function and their own logic. So we're going to create a service that will be able to do each one of those actions. So now that we know what to expect, let's get started. So let me right click on this services folder, create a new Kotlin class. I'm going to call this to-do service. And very similar to, or actually let me zoom this in. All right, cool. A little bit more. And now very similar to the repository, because you remember in repository, we use the annotation called @repository. This lets SpringBoot know that this is going to be a repository file. But another important thing that this annotation does is by default, it is a component. Now, what is a component, right? So in SpringBoot, a component allows for our application to scan classes to see where a component is, right? So what does that even mean, right? So when we start an application, SpringBoot scans for components, and if it sees that it is a component, it will instantiate them, and it will allow us to inject it into any dependency that needs them. Now this is actually pretty cool, and we're going to see an example of this in a couple of minutes, but I just want you guys to know that our repository by default is a component. And now when we go into this to-do service, we can also define or let SpringBoot know that this is going to be a service by using an @service. And by default, this also is a component. So now wherever we need to use this class, or wherever we need to instantiate this class, SpringBoot already handles that, because when this application starts, it's going to check to see, it's going to scan the application to see where there are components, and it's going to instantiate them. And then wherever we need to inject that instantiation of it, it will do it for us. And we can use an annotation called AutoWire, which will inject an instance of our object into a field. And SpringBoot will handle creating that, like I said, managing it, and destroying it. So this is why it's so powerful to have these annotations, because it lets SpringBoot handle a lot of things in the background that you guys don't have to do yourself. You don't have to do manually, all right? So let's see an example of annotation. So we're going to use this annotation of @AutoWire. And let me just import that. And then we're going to actually create a field to store the repository. Because remember, if we look back at the chart, right, it's controller, service, and repository. So from the service, we should be able to communicate with the repository, and the repository will communicate with the database. But the service has to send data from the service to the repository, and then the repository can send that data to the database. So we have to have a way of communicating with the repository from the service. So we're going to create an instance of the repository here in this service class, and we're going to use the @AutoWire to inject an instance of our repository into the field that I'm about to create. So let's just do late init var, and then we're going to call this to do repo, and then that is just an instance of to-do repository. Now, what is this late init var? That's just literally letting Kotlin know that eventually this to-do repo will be instantiated, because when this application starts, AutoWire, what it's going to do is first it's going to scan for all the components. That's what SpringBoot does. It's going to scan for all the components, and then this AutoWire is going to pick up the instance of that component and it's going to inject it into this to-do repo variable, right? So now we can start building our logic for us to be able to start communicating with the repository so that it can save information into the database once the controller sends information to the service class. So the first thing we're going to do is we're going to create our function to save a to-do, right? So let's create a function. So fun, we're going to call the function SaveToDo. We're going to open up the we're going to start defining some parameters, and then what we expect to come in is an instance of a to-do object, because when we receive a request, it should be in the structure of a to-do, and when we receive that structure for to-do, we're going to use that same to-do structure to save that information to the repository, to the database. Because remember, we defined the to-do as an entity, and that's what the table is structured to look like. So that's how we should expect the controller to retrieve the request. It should be in the structure of a to-do entity. If it's not, then we'll have to reject it, because we need information in the structure that we defined. If not, then it's not needed. So what we're going to do is we're going to take in a to-do. So I'm just going to call it to-do entity, and it's going to be of type to do. Then we're going to open up this and start defining some logic, and really it's going to be a one-liner until we start defining some exceptions later on. But for now, what we're going to do is what we're going to return is we're going to take this instance of the to-do repo, and remember what I said with the repository. If I go into repository, we're extending the JPA repository, and that includes some CRUD API or some CRUD API tools that we can use to save, to delete, and all that good stuff with our database. We don't have to define it ourselves. It's already implemented in the CRUD repository. Now we just have to just leverage it. So what we're going to do is make a call to do repo, and we're going to take advantage of some of the methods that are already defined in the repo. So as you can see, you have so many methods. You can save multiple using save all, you can delete, you can find all, you can find by ID. There's so many things that you can use. And if we go back to the repository, we didn't define it here, but we're extending the JPA repository, and that is already created for us. Now we can just leverage it. So what we're going to do is we're just going to save that to do entity, because when we receive this entity, right, we expect to receive it in a structure that we expect it to be a to do. All right, so then now after we finish saving it and we're returning something, after we finish saving it, it's going to return an instance of a to do. So that is what I'm going to do, and then we can just use you don't have to, but my Java knowledge, right? So that's pretty much what this is going to do. We're going to save an instance of a to-do entity that we retrieve from the controller, and we expect it to be in the structure of a to-do, and we're going to use the to-do repo to save that information. That's going to communicate with the database to save that information in the structure of the entity. Now what's being returned is when we save this entity, what's being returned is the to-do that was saved. So if this is saved properly, then it's going to return a to-do entity, and you will see that the ID is populated with the correct to-do ID that was generated. Because if we go back to models, right, let me just zoom in a little bit. The ID is going to be generated for us. Title, description, and progress should be what was sent in our controller, but created that is going to be created for us, and updated that is going to be created for us. So when we go into this to-do service and we save using the instance of the repo, we should expect when we save to return everything populated as we expect. So it should return ID, it will return all the timestamps that was generated using the annotations, and it should return the title, description, and progress that the person specified in their request. So that is the SaveToDo function. Second function we're going to create is the UpdateToDo. Now this is going to be probably the thing that has the most logic, and like I said, we're going to define exceptions later on because things are bound to break, but for now I want to keep it as simple as possible. So what we're going to do is create a function called UpdateToDo, and I'm going to open that up, and I expect to get the to-do entity. All right, and I also expect a to-do ID because in the request URL, I may expect that they send a ID to confirm that that's the specific ID that they want to update. That's a specific to-do that they want to update based on that ID. So what I'm going to do is get the reference by ID. I'm going to try to check if the database has an instance of that specific to-do using the ID. So we're going to make a quick fetch using the ID, and if it's there, then that's great. That means we can take what was in the database, update it with the new information, and then try to save it again. So that's what we're going to do. I'm going to create a file, new to do, and that's going to be of type to do. Make that equal to do repo, and then I'm going to do the get reference by ID. That simply means that what we're going to do is we're going to try to go into the database, search up the to-do table, and then check if there's anything with that specific ID that I'm passing in. So in that case, it's going to be the to-do ID because that is the to-do item that the person is trying to update. All right, so now that we got the to-do using the ID, now we're going to update all of the items within that object with the new data that the user wants to update. So what we're going to do is take this new to-do, we're going to take I'll start with the title, and we're going to make that equal to the to-do entity that the person is sending through their request, and we're going to retrieve that title. And then we're going to do the same thing with description and progress. We're going to make that description equal to the to-do entity, which is the entity that the person is sending in through their request, and updating that. And we just keep doing that. The last field is going to be progress, and to-do entity progress. So if they're the same, then it's fine. That they're going to be equal to whatever it was before. They're the same. But if anything was different, then now we have the updated value, and we're going to pretty much assign that to the object. And then after everything is updated, now we're going to let the to-do repo know that we want to save that. So we're going to do to-do repo, and we're going to do .save, and it's going to want an entity of type to do. So we're just going to save the new to do. And I keep forgetting to make this of type to do because that's what it expects to return, and that should go away. In the future, there are many edge cases that can happen, many errors that can happen. First of all, like what if that to do ID is not authentic, right? So, and also what if there's a problem while saving, the DB is down, stuff like that. We will handle exceptions later on, but this is in a perfect world type of scenario that we can do this. But later on, we're going to go over exceptions and how to cover all of this to handle exceptions and what to return back to the user. But for now, this is a perfect scenario. So we're halfway there. Let's create another one, and the last two are pretty short. This is actually the longest one, but the last two is either retrieving all of the to-dos and deleting a to-do. So let's do retrieving all of the to-dos. So let's create another function. We're going to call this retrieve all to-do, and we're going to make this of type because there can be multiple to-dos that we want, right? So we're gonna do list, and we're gonna do this as a list of type to do, and this could be nullable because what if it's empty? And then what we're gonna do is we're just simply gonna return to do repo, and then we're just gonna use the find all method. So find all the to-dos within this to-do table, because remember the to-do repo is just pointing to the to-do table, and then it's just gonna find all of the instances in there, and we're good to go. Pretty short though, right? Just return all that. And then the last but not least, we're gonna create a function called DeleteToDo by ID. All right, and what we're gonna do is take in a to-do ID, and we created our ID to be of type long, so that's what we should expect. And then we're gonna grab or open that up, and this is also pretty simple as well. We can do to do repo dot delete by ID, and let me just type that out because there's a whole bunch of ways you can delete something. So delete by ID, to do ID is what it expects. It expects a long, and we are good to go. And this is a void type, so it doesn't return anything, but we could return like a string or something that just shows deleted if needed, which I'll do, and I got to specify that it's going to return a string, just so that you know that it went successfully. But cool, so that is the 4 functions that we're going to create for our service layer. One to save, one to update, one to retrieve everything within the database, and one to delete based on the ID. All right, cool. And we also learned that we can inject an instance of our repository just by using AutoWired, because we use this @repository annotation that pretty much makes this a component, which when we start this application, SpringBoot will scan for and create an instance of this repository, which will allow us to be able to inject it just like this. And we specify this is going to be a late init because we're just letting or promising Kotlin that we're going to instantiate this variable eventually, right? Because this AutoWire is going to do it once we start up our application, and once that is instantiated. So this is cool stuff right here. So now in the next portion, we're actually going to create our controller, which will allow us to accept requests, and then that will allow us to funnel those requests to this service. And then we saw that we're leveraging a lot of the repository to communicate with the database, and then that is going to allow us to return that information back to the controller, which will then take that information from the controller back to the user, which is called a response. So yeah, we're learning a lot, so let's keep it going.